Okay, let's get into it. We're doing a deep dive today on what is, frankly, one of the most philosophical ideas in AI right now. It's called the Platonic Representation Hypothesis, or PRH. And the core mission here is to figure out this claim that all these massive AI models are somehow converging on one single shared way of seeing the world.
It's a fascinating shift
Yeah.
because, it wasn't always like this. AI used to be so fragmented. You had CNNs for vision, RNNs for text, and, well, each one had its own totally bespoke internal logic. They were islands. PRH says that as these models get bigger and bigger, that fragmentation it breaks
So is it
down.
like Plato's cave?
Exactly like Plato's cave. The AIs are the prisoners. One is trained on shadows made of text, another on shadows made of images. But somehow they're both starting to figure out the same underlying reality that's casting those shadows.
Which brings us to the core question, right? Are they actually discovering some objective truth about the universe? Or is this just an echo of all the human bias in the data we feed them?
That is the question. And the main theory for why this happens actually comes from, of all places, Tolstoy. It's an adaptation of the Anna Karenina principle.
All happy families are alike.
Right. In AI terms, it's all strong models are alike. Each weak model is weak in its own way.
Okay, I get the weak model part. They're all unhappy families, they're all buggy and noisy in their own unique ways, but the strong models being alike. I mean, the pressure to minimize loss just forces them to give up their weird habits.
That's the idea. The overwhelming pressure for performance basically bullies them into finding the single most optimal way to encode the world's statistical patterns. There's only one best answer, and they all have to find it to succeed.
But proving that feels impossible. How do you even compare the insides of two totally different models? A language model and a vision model don't even have the same number of dimensions.
You use something called centered kernel alignment, or CKA. It's brilliant, really. It doesn't look at the specific neuron values. Instead, it compares the relational geometry.
The geometry.
Yeah, so it asks, how does each model group concepts? If your model and my model both think dogs and wolves are similar, our CKA score goes up, even if our architectures are totally different.
And the MIT Wikipedia experiment found a direct link here.
A stunningly direct link. They found it a near-perfect linear relationship. The better a model performed on, say, ImageNet, the more its internal geometry aligned with other top models. It was an R value of over 0.9.
Wow. Okay, so better models are just more alike
Yeah,
internally.
exactly. And the most concrete sort of mind-blowing example of this is the Spider-Man neuron.
Right, in multimodal models like CLIP.
Yeah, you have this one single neuron that fires when it sees an image of Spider-Man.
And it also fires for the text, Spider-Man.
And this is the key. It also fires for the text Peter Parker. It's abstracted the idea, the platonic form of Spider-Man, separate from any single way of seeing it.
That one example makes it feel so much more real, and the practical side of this is huge.
Oh, it's a game changer. The biggest implication is the universal translator. If PRH is true, we get zero-shot interoperability between models. You can just snap them together.
Like Lego bricks.
Like standardized Lego bricks. Your vision model and my language model already speak the same internal geometric language. We just need to find the connection points.
So, beyond the engineering, what does this mean philosophically? It suggests that ideas we think of as, human constructs, things like justice or cause and effect, are maybe not constructs at all.
It suggests they are robust statistical features of the universe that any powerful enough intelligence would eventually find.
And the brain score benchmark seems to back this up.
It does. It shows that our best performing AI models are the ones whose internal representations most closely match the human visual cortex. It's like evolution and gradient descent arrived at the same solution, the same platonic representation through totally different paths.
So we're shifting from a process of pure engineering more towards a scientific discovery. We're not just inventing intelligence, we're discovering its fundamental geometry.
And that leaves us with, I think, a really profound final thought. If the human brain and AI are both converging on the same internal map of the world, because they're both constrained by the same physics, does that mean any alien intelligence out there observing the same physical laws would inevitably discover the very same platonic forms we're starting to find?